Here we go. Hello everyone. Welcome to the stream. Oh, everything fell down. Hey Dutch. Hey Dutch. Two Dutches. No cheese fondue today. So Dutch maker, are you back? Are you back to Netherlands with a new batch of LEDs? Are you ready for the new summer season? Garden lights summer season. You probably make like your most income in winter before Christmas, and then in the summer when people install their LEDs outside. Fashion loony. No, it's not fashion. I'm sick. Hey Sonic. Is it working yet? Hey Adam. Oh, I'm yes, no, partially. It's working on the MCU, but it's not working in the cluster yet. And this is our mini goal for today. Make it work on the cluster. And we have to do some soldering, maybe, to fix that, because we have no clock on for communication with the cluster. Hey Nishai. I had to restart my PC, so I hope I can find everything. Raymarching MCU. Yeah, need to be careful because I have planned all my taxes. I had to do my taxes, and I don't want to dox my personal tax information. It was so much work. I spent 3 days just collecting the receipts and the traveling expenses. I had like, I don't know, 10,000 euros in traveling. No, it wasn't 10,000, but it was a few thousand traveling expenses 2023. HPIB. What is HPIB? Hey Johnny. Hey Wagon. So I can maybe show what we achieved recently. A web. Still in China. Summer holiday, August back to Netherlands. Oh, RGBW samples looking very nice. Man, this is your life. It's revolving always around RGBW stuff. Hey Z80. Alright, so let's take a look. Comparison. We started with... Oh no, wait. Let me switch to this one here. Okay. So this was the raymarching in browser. Then we have a raymarching in fixed point. You can already see bugs in the fixed point calculations here and there. So that works fast. Then we have fixed point in tasks. So this splits up the calculation into individual pixels and then worker task calculated. Then we have MCU, which is running on the MCU I think it's even connected already. Look at this. Raymarcher? What? 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 it It's calculating on an MCU? Yeah. Hey, Richard. Hey, Basil. Yumbo, yeah. So it's actually calculated on. And the code, I updated always the repo when I had something working, running. And I tell you, the worst part of all was getting CDC working. So I tell you all the journey that we missed since last time. I worked my ass off last week. This week I did the taxes, but last week, did I zoom in? Okay, switch the camera. Can I switch the camera? Not visible. Okay, let me turn it on here. Okay, yeah. Here, this is the 28, which has native USB, but the CDC, I tell you something. Let me tell you something. Let's start Moon River. 5 years now working on these RGBW. 2 years make big steps. Wider gamut, pure green with high purity in 18 volts, 2436. Still tweak 48 volts. Nice. Peter! Cheers back to Boulder. Okay, so here is the issue. I wanted to. So this is communicating now over serial. I mean, it is a side project, but you have simulate CDC is a project, but this is a C project, and all the examples are C projects. So there is no way. Oh wait, the system here. It's really hard to compile C++ code. You have to change the setting. I can show you maybe. I have this done here in this one. We have like a main C which does nothing, and then CPP, because you need to change like all the compiler settings and reset. Wait, here settings. Add all the includes again, and I don't know. There was like ton of things which are not obvious. And WCH, they provide a tutorial, a PDF, how to convert a project to C++ with new and then other, and you can do convert to, but that didn't work. I had CDC render. I think I deleted this project. It compiled, but it didn't actually compile. The code wasn't running or something. I don't know where it ended up. It wasn't executed or something. And I was always wondering, oh, what's going on? The CDC wouldn't show up and whatnot. So it was like not working, and I don't know. I gave up at this point. And my journey continued. Oh well. Slick Looney. No, I am sick. I am sick Looney, not Slick Looney. Okay, so I thought, oh well. So if I want CPP, I should move on to PlatformIO. And the funny thing is, for generic CH blah 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 208, you can select. Let me show that. It's so hard to explain again. Where the settings? No, where? No, not the steps. I want no platforms. Have a little brandy. No, I had pain meds. I don't want to kill my stomach. What? What is this? Okay, forget it. Anyways, there is. You can. I found an example from someone. A Japanese guy. I'm so sorry. I need to link it though. Maybe I find it. CDC CH203, I think. I will never CDC example. Oh yeah, I found it. I think, yeah. So maybe I add this also to the info here. CDC code based off here. And this one here, apparently it's a working CDC example, but it's for PlatformIO Arduino IDE with... Oh, you need to rewatch, Rohan. You need to rewatch in twice the speed because I'm in the middle of explaining what happened since last time. So we have a rendering MCU already. So this is how the MCU renders. Wait, let me reload. It auto connects again. So this is one MCU that's rendering, the 208, the big one. Anyways, so but this library, the 203, the Arduino Tiny USB Arduino doesn't support the 208. I don't know why. It's not supported. So you can select PlatformIO. Let me save that. You can select PlatformIO basically the framework. Arduino isn't supported for this MCU, and we have only like CH Fun from Charles is one SDK, and we have non-OS SDK, and then we have I think there was like RTOS, but I think RTOS is too overloaded for that. So I went for non-OS SDK. Okay, I wanted CH32 Fun SDK, but it didn't work. I compiled it and it didn't work, and the problem is that you need to run the MCU of a specific at a specific speed. So let me show you system fix. Yes, we're switching to platform. I hope forever. I don't know. Maybe. I want this project to run on PlatformIO. Hey, Kaspar. Richard. Yeah, it's Blender or PovRay. Anyways, where's the main? Wait, what? No, this is... right into main. Okay, so the issue is usually what happens here in Moonriver SDK with ch blah 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 SDK, you have the system 32, and then you switch to 144H internal, like high speed internal, or what is this, PLL internal clock. So, and then the system clock is set to 144 megahertz. All right, and this part is basically hidden here in the SDK, and you can't access. You have to change it globally for every project manually, which renders it like unusable for this example. So non-SDK, there is an open issue in the repository, but it isn't maintained. Cluster kind of works. And the same issue is with CH32 fun. The problem with CH32 fun is you can set up the internal clock 44 megahertz, but they don't use like the generic SDK functions, and somewhere there is like a setting wrong, and it just doesn't work. I don't know why the USB doesn't work, even though I switched to 144 megahertz. And since the non-OS SDK is basically a copy of the Moonriver stuff, I just copied, wait, or is it system fix? I just copied the method to, Cosine, thank you for the sub. Too much trouble. Switch to Notepad and make files. Yes, maybe. So I just copied the method that sets to internal 144, and then I'm also calling the method which basically determines, like sets the global variable for the clock speed according to the register. So there's basically, if you look at, it will just set the system core clock here. This is system core clock update. It does basically that. That's all. So, and then the CDC showed up, and it's only working with if you download it with PlatformIO non-OS SDK, and this is the state. And the funny thing is, what I really like about the implementation, also those files that the Japanese dude used, they are basically a copy from the implementation from here. So it's just put together. You have like a USB driver. That's that stuff. It's basically the same files. There is one interesting thing, descriptor. You can change the descriptor values and names, and this is where I switch to raymarcher and manufacturer's bitluni, and I set a distinct device ID is FFFF. I kept the vendor CH, WCH, and just set the, so it's recognizable, and we can filter it in our renderer. So wait, let me show the renderer. Where's the renderer? Oh wait, that's not in this file here. This is the, okay, so this is vibe coded. No, wait. Yeah, MCU. This was vibe coded. Binary sample data. So I basically tasked ChatGPT to generate that. And the funny thing is, it can filter whenever if you just approve a device once, whenever you reload the site, it can automatically connect if it's the product ID, vendor ID, filtering. You can just reconnect. So if I reload the page with the renderer, I don't need to click connect serial again. I can just click render and then it's already connected. So that's a cool thing. But this is only a side project because the final cluster doesn't use like the USB stuff. So we have like this part. Yeah, here the serial chip, PCI Express serial chip, and there is an issue with that as well. So what I discovered, okay, that takes like the rendering of on the CH32V208. It takes like, what is it? Yeah, MCU graphics. Yeah, but here we go. One thing. Wait, why did I reload it? Okay, if we render it, it takes like 30 seconds or something to render. Yes, it's basically rendering on this one here. If I unplug it, wait. Can we do? If I unplug it, it's done. And the funny thing is, if I continue render or something, there might be... Does it connect? Okay, I need to probably reconnect again. Yeah, it's broken. That's some buffer. Yeah. Yeah, fun adventure. Why is it not full? Sorry, I probably can't stream for very long today. Okay, it's like, I don't know, it's like maybe a minute or 30 seconds. What I calculated is this MCU, oh, it's not getting really warm. This MCU is clocked 3 times faster, like 144 megahertz compared to these here. These are only 48 megahertz, but else than that, they're comparable. So basically, on one of those tiny 10-cent MCUs, this would render like 3 times longer. But with all the MCUs populated on this one here, we have 160 MCUs. Cheat code: if connected, render is stop. Yeah, and I think no, not sure if, yeah, might be able to start rendering right away. Anyways, with 160 MCUs, it would be capable of rendering the frame in half a second or something. That's what I calculated. But the problem is, currently we have only 115 200 baud. So 115k baud rate is what is it? Like 15 kilobytes a second. Am I right? 15 kilobytes a second is not enough to transfer a whole frame in 1 second, especially as we return colors in 3 times 32-bit plus overhead or whatever there is. Game Boy on cluster, maybe, I don't know. Here we go. So the problem is I need to switch. So 1 mega. Okay, Basil, this is now, I know the math, the linear algebra stuff wasn't your thing, but your thing is the hardware stuff. And this is where we got the problems. Because, let me open the data sheet. It's a lot of updates and talking, but I want to share and document basically the efforts that I went through to... Oh, so yeah, you can find the whole project with all the code already on my GitHub. So when we... No, where is it? No, I think... Is it code? Yeah, it's not very nicely organized here. No. This is the wrong. Okay, wait, PCB. Here, datasheet. Here we go. Okay. UART. This is what we need. We have this configuration here. No external crystal. There is this part. We have basically default setting. Division of 1 to 68 is enabled. There is the possibility to transfer up to almost 8 megabits per second. If we have like the divider set to 1. Alright? Now, what we need to do for that is to change those flags on the flash. I bought flash chips and you have, I think, where is it? IO register. Here, something like that. Here is something, bits. So you can do it, set it on the flash. The issue now is that when I start the tool to change the flash of the card, here it's provided with the driver. There is a tool, nice. That's a baud rate calculator. We have a configuration tool. It's x86. Huh? What's that? Gen PWDM password manager, generate password, sys failure. I couldn't find anything about this driver or what's expecting. But the issue now is that this, oh no, it hits everything. When I try to find here, nothing. Can't connect. How do you do that? Sonic, how do you do that? I need your people's advice to do it. I have no clue how to run that. I tried compatibility mode. Okay, so I tried compatibility here. Oh shit. It hides all my other windows. And then I think... Oh wait. It is signed. What? Trojan. Hey 44. I have no clue. I would totally take a Trojan virus if I can configure my flash in the end. Someone sending me info. Sonic sending information. System recovery. Advanced start your device to change startup settings, including starting from disk or USB. Get the Chinese fork of Windows. What? Okay, so startup settings and now. No, I just my screen went black because I moved the window and then Windows decided to good night. Basically hit everything. All my, where is the tool? Every window was minimized. I don't know why. I just touched a border or something. So what do I do there? System recovery. Good night, Dutch. It's late at your place. Restart now. I'm not restarting now. What? Oh, change the default language of the system if that's a Chinese. Ah. Yeah, I asked Patrick, but I have no response yet. Why it's not working? That might be a thing. Sonic, I don't understand what do you want? What do you want me to do? Restart the system? Should I reboot right now? Wait, I can do it on the small device, but I don't have the flash chip soldered on yet. Anyways, my task is, but is it an issue of driver signing? German doesn't help you to read. Oh, sorry. Might be. Okay. Wait, you know what? We can try this with the mini PC. Let me start up the mini PC and then we can run it. Japanese. Okay. Yeah, I can't see it either, and I can't find it, and it's either I don't know if it even exists. The second device to destroy the OS on. I have no clue where that is coming from. Kernel module, so it's a kernel error. Perma language setting incoming. The tool? Oh, you can just download it from WCH. It's the driver here. Wait. I can give you the link to the. You need to. I think you need to get the zip file. Otherwise, yeah. The executable won't probably expose the thing here. That's one here. Download. Okay. I will give you the link if you want to play around. So I'm interested to, I need to make this run so we can put it in super fast mode in the end. Anyways, now before we do a short break, do they have a Linux binary? What? No, I don't think so. I didn't see one. So there is nothing there. That's just tool. It's just that. Here you have you can, I don't know what, you know what also the issue could be, that's an x86, but I don't have an x86 system. But is this, it is signed here. It is signed. Yeah, I think 32-bit, but can I access my PCI Express in a VM? Yeah, it's causing error. Yeah. Load failure and then What? Yeah, so I probably need to run on a 32-bit system, but I don't have one. Even the mini PC runs 64 bits, does it? Yeah, at least it didn't work there. Wait, let me connect. Time to visit a museum. Oh, I didn't turn it on. Here. This is terrible. How do I program it? Yeah, but on driver level, I don't know. My kernel. So where does it run on Linux now? Should work. Let me check if we can get what we get here. I know it doesn't run on the mini PC either, so but this is also 64-bit, I believe. The issue is all my PCs that have an M.2 slot are basically 64-bit devices. Here, 64-bit based PC, damn it. I just want to configure this stupid thing. You know what else I could do? I have those serial cards. This is also built in this PC. They don't have the flash chip. They have only the place for the flash. I would solder it on, program it on the 32-bit Windows, and then desolder it and place it on my M.2. This is the only way I see right now. Windows 10 32-bit? Yes, there should be. I don't even care. I would take Windows 7. I would even take like Windows XP. PCI Express M.2. Oh yeah, expansion card, that could work. But then I need to buy an interface card for that. Oh damn it. So much work. Alright, so this is the issue, and long term we need to switch to higher transfer rates. I would VM, can I access? I can't access PCI Express over VM, can I? I would even start from a stick if it was possible. Like start from, I don't know, different hard drive or something. External hard drive. Install Windows 32-bit. You know what? The idea with the PCI Express card is not that bad. IO. Okay, people. If you want to help, you have the access to the stupid executable. If you find a simple way, an image, VM image or whatever that will work, just tell me in the end and then I'm happy. I will try it. For now I can't do it. What I would do, I would go on eBay right now and then look for PCIe-M. You don't want to help? Alright. Look at this. Yeah, but this is probably from China. $6.99. I guess I could do it, but I don't have like this wide. Damn it. I think this cheap PC. Oh, you want the data sheet? I can give you data sheet. You will get the data sheet in, what is it? Yeah, what X1 works. Data sheet is here. Yeah, you can send a link. Wait a second. Here, now you have the. Okay, there is the data sheet. Let me check. Artikelstandort Deutschland. Yeah, and you needed moderator rights for that. I gave you just. There is no X1 card though. Is this times 4? The Windows PE? No. Wait, let me check what kind of PCI Express I have on that one. I think it was times 1. What did we have? Because I think this one was 32 bits. Ah, yeah, it's times 1. Fuck. But what is this? Is this PCI Express? There is a graphics card though. Oh, that could be AGP. Windows. But I have an image of Windows 32-bit somewhere. You can just download them anywhere. PCI Express times 1. I don't think there is a card because you have like on M.2 you have multiple. Wait, this is one. Yes, this is the one. Wait. Yeah, this is times 1. I don't know if this will even work. I mean, that looks really crappy. Huh? 3 times 4? Doesn't look like times 4, it looks like times 1. The description is wrong. Huh? From space. Here. Amazon. 9 euros? Are you crazy, Sonic? Are you mad? Okay, I can get it tomorrow. Oh well, I just buy it. Let me just buy it. Quality. I almost doxed myself. Alright, it's coming. It's coming! People, it's coming! It's coming! Oh no. Did I use the right payment method? I hope. Shit. Business expenses, my friends. I can see where it out. It's a few bytes. Yeah, I could flash it externally with a flashing tool like this one here. Where is it? I have my flashing tool just here, somewhere on my table. Oh, Richard, you. Oh, wait. Yes, might have been. Wait. I was super busy because I did my taxes. I saw your email already. Wait. Yeah, Richard okay. Richard Hale, yeah, your name. Create SPI ports chain. Yeah. I read it, but what do you mean with help you? How do you mean that? Won't find the sys. Yeah, we will just copy the sys in the same folder. But we just need to find the file. Okay. Next point. Very strange Google results. Yes, I'm also confused. Also errors. Okay. Yeah, I need some something for my throat. All right. So very strange. Now we have this code here. Tool. There is a folder tool. Just run tool and see what happens. Caspar. There is a tool folder. I don't know. You probably need to do get update. And then get upgrade system. Yeah. Recompiling the kernel. Anyways, we need a new project here. So this is... Wait, how do I... Oh yeah, I installed the drivers. The drivers are working fine. Only the tool doesn't work. You probably need to install the drivers as well. And after you install the drivers, run the tool. What's with the PDF? I dropped a link before. Document downloads. Just scroll up. There is the document. What do you mean? Yep. I never used SPI on that before. Richard. What? Are you kidding me? Oh, what? Still. Nice find, but still the same problem. So it just runs from temporarily. But then we have the Gen P DLL, Gen P. Should we check? Where's my hex editor? No, no. You can have them locally. PCI TFG. No. Yeah, all right. It certainly can't run in DOS mode. At the end of the DLL, we can see the names of the DLL. If they're dynamically linkable, we can see the names of the functions exposed. That are just the long strings. Gen port, gen. Look at that. These are the functions. It's basically PCI stuff. Read, EEPROM, read, find, CH35. Yeah, that's a generic. The name is probably ambiguous. What they just do, they have like all the stuff here. Kernel level driver executable. You don't believe me? All right, you experts figure it out. Other than that, we can just take the DLL and run it. A Krautstreif. You heard Linux, yeah. Anyways, you peeps figure it out. Now, I want. How do you generate a new? How do I do a new project? PlatformIO. It's so default. How do I open new project? Okay, here. Project name as raymarcher 003. Board. Yes. Which one is it? C8T6? No, wait. F4P6? Which one is it? Yeah, it works somehow. Like the USB CDC didn't work. I need to check. Oh, what's the name? I forgot. F4. Okay, it's an F4. F4 U6. Okay, now we can. Should we, or do also non-OS SDK? we stay true. But I like. Okay, let's keep it. We can. Oh no, not default location. Oh fuck. Always do the same issue, the same. It's the same like non OS, yeah. Oh, raymarching cluster raymarching. I just hate this. Okay. Cluster raymarching. Wait, does it create the? I hope it creates a new folder. Can kike an external video card slots? Yeah. But routing PCI Express lanes isn't very easy. Wait, where am I? Where am I? Okay, cluster raymarching. Serious, yes. Some serious. I mean, maybe the longer the lanes, the slower the speed. Relativistic speeds. Okay. What? Huh? Where's my project? Why is it so confusing? CDC. This is the CDC renderer. Okay. Gotcha. But where is my... Did it open a new... Where is my new file? PIO home. You pick the project and it will install automatically. But... Huh? Here we go. Where? What? No. You have to type CH32V. Okay, I don't know. What? Maybe you need an update or something. So if I go PIO home, open, a new project, 1600. So CH32V, and then you get plenty of options there. I don't know what I did. Okay. Okay. So now we need to copy our codes from, yes. Oh yeah, I need to turn off the other computer. What did I install? Something installed? Okay. Let's compile it. It return. What doesn't like? Undefined reference to main. Oh. All right. My object, no. Okay, here we go. Let's try again. Okay, here we go. Now the issue is I need to find system init. The problem is we can't set the speed as well here, like so I have cluster M.2 supercluster 2. Okay, so this is my code. I just copy the shit. We can just copy that. Let's see what it likes or doesn't like. Oh yeah, bus. We don't have a bus here yet. No implementation of bus. We don't need bus. Where's the include? Here. Ah, setting up, yeah. Bus set index. What? Where? Oh wait, that's an actual bus. Yeah, that's my definitions. Okay, all right. I had some definitions there. So let's add it. Source. Okay, let's do it. What problems do we have? Is this some code that... Where is this code coming from? Oh, yeah. That's coming from CH library. CH32 fun library. Okay, anyways, yeah. We can do whatever to get rid of the warning. Okay, here we go. Right. So this will probably run. I need to check if I can even run it now. I need to plug in a card. Okay, can we upload it? Did it work? It worked! I think it blinked. It blinked once. Okay. So let me plug it in. Okay, they have not programmed any MCU IDs. Oh, and also the renderer doesn't trigger them. So what do we do now? We should see if we can put there's stuff going on. Hey, Monroe. Thanks for the sub. Or was it follow? Anyways. We just added stuff here. Yeah. That's CH32V project added. It's committed, but I need to find out what. Oh yeah, I mean, a group effort here. Or do you mean we? Even when I'm alone, yeah, we. You're only alone with your devils or demons. All right, here we go. I tend to use also we in my videos recently because it's a group effort here. I really want to acknowledge the thing that you all contribute. the evil loony and the mini-me loony, I don't know. Okay, system clock update. I want to... Okay. Left brain, right brain. HSI. Okay, so This is, I think this might be, I hope this is, let's see what's configured here. Ah, no, this is wrong code here. Because the non-SDK stuff, it's not defined. It's not defined, my friends, it's not defined. Shoot. Okay, let's find this here. No, wrong code here. Here we go. External. We need to have this here. Include file? What do you mean with? 24 here. So this is basically from the SDK hard coded. So I just copy that. I'm lost. I don't know what you... okay, here. New file. System clock. Wait, system clock fix. Where is it? Here. New file. H. Okay. Because I don't want to change the SDK files, otherwise it will only work at my place. Okay, that, and then we need also to update. Yeah, I don't here, no changes. Wait, no, wait, This is all right. Okay, and then we need to, where is it? This here. So, and we need to include what? What did you paste? I am not very familiar with PlatformIO, so here we go. That should compile with external fast speed here. Nope, it doesn't. It failed. Oh yeah, but that's done automatically by the PlatformIO stuff. Is it? Isn't it? H fix here. Deleted that beforehand. Okay. Oh yeah, that doesn't work. Okay. Doesn't work when USB is connected because it does power cycle. All right. Here. Oh, okay. Really? Huh? Okay, I'm lost. Um, non-OS. What is non-OS? Or what's the SDK name? I see it. Oh. Oh. Okay. Maybe this is somehow missing in the debug. Oh, this is strange. Version. Okay. We can add this header though. If you like. So oh. Okay, I think it compiles. No, sorry. Yeah, I will just commit it. Added include for weird systems. Here we go. 404, and it's for you. Oh. Okay, clock is fixed. Now, can we put a raymarcher on there? So source, new, oh, no, new file. New folder. You were out for a second. Oh no! Here. Wait, here, this, I did it for you. Edit include for, edit include for weird systems. Just the include. I don't know if my system is weird, but this weird is relative. It's like yeah, what I wanted to do is add new folder raymarcher, or was it ray renderer? I don't know. Forgot about how it was implemented. GAOM.2 matrix Betriebsausgaben. No, that's not the folder. Hä? Where's the folder? Cluster raymarcher. Here we are. Okay, so CDC renderer does already have that. Or here we go. I should just copy that. We can do that and just cluster raymarcher, source raymarcher, and then add this code, and then the only thing missing yeah, we need to fix the addressing. The addressing, not the addressing. So there is some stuff going on with the bus. Wait. Raymarcher. Did you convert the raymarcher from? Yes, I did. It's all in the repo. Look at this. Cute fixed point math just for you. It looks way cleaner. I didn't overload. I didn't want like to rewrite everything. Otherwise, I would use like operator implementations here. So you could just work with, I just kept everything as it was. Yeah, there was no way around like using the same scene everywhere. At some point, it should be serializable, so we can serialize scene, send it over, and just initialize it before we start rendering on each of the MCUs. So that's a future project. Or like we try to function first and then optimization last. Anyways, everything is implemented in C++, so you figured? What? That's it? Yeah, but I need to flash it. That's like, how many bytes is this? Like 32 bytes or something? Oh, damn. I knew you would do it. Wait. Let me copy that thing. Wait, but where's bitluni? Yeah, but where's the name? What's that byte string? The byte string is the flash contents for improving the speed of our serial PCI Express serial chip. Where do I put it? Okay. It's in my stack right now. Okay, include. Oh, really? No strings? What? Oh no. Yeah, that's true. That's true. Drivers won't work. Or I hack the drivers and change the ID, and but then they're signed, aren't they? Yeah, we can change. We can't hack them. Same result here. Nothing works, and you are not only. Yeah, I poked Patrick. Let's see if he reacts on that. Scene render raymarcher H. What was the ray we can do? I think it's down here. Render pixel and then whatever. Okay, so isn't the def ID or type ID a unique ID each of the MCUs? Not device ID, type ID unique? No, the device and type ID might be. I mean the manufacturer ID for that's USB descriptor. We're talking about USB descriptors or not descriptors like driver. Yeah. So we need to use WCH because that's their chip, and they have probably for each chip. Yeah. We just keep it and then F this, I don't care. We will identify it and use the right ID here. PCI Express IDs, yeah, not USB in that case, true. Okay, it compiled. Wait, did it compile? Let's clear it. RAM. Yeah. Slash. It probably optimized away. I think we're using more code here. Anyways, I want... Oh, render pixels never used. So read user byte 0. That's here. Programming phase. That's the programming phase, but we can do too much. It's doing too much. Not set index. Boss, what do we have? Right flash. What AI? That's what's this open source thing called Copilot. Oh, boss. Pixel. Let's start with or x4 0. Now let's initialize renderer, initialize scenes. Yeah. Maybe we should raymarch init. Okay, we have init if we need it. Raymarch pixel. I think it knows all the project, all the code. At least it knew render pixel. What is this is too much. I don't want that much. What is this crap? Bus blink delay. It's all right, yeah. I guess blink bus execute whatever render pixel. Wow. Okay. Oh yeah. we need to fetch poll the result. Where is it? So long define. Okay, here we go. Int mania. I mean, it does something now. Now it should barely fit into the flash. No, it's still the same. Flash 4000. Hey foo! How is Colombia doing today? At least you might have good weather compared to us. It's so cold in Germany. Look at me, I got a cold. But wait, Colombia is quite very sunny day. Yeah, you're quite in the mountains, so you can have it either way. If you go high, there is cold. Alright, this is wrong. VS Code. Quite hot in Poland? Yeah. What? No, I have fleas. It's windy and cold. During the night we had like 5 degrees C. Yeah, 20 degrees during the day, quite windy, but in the night it's cold. In the night it's cold. Here we go. All right. This is chaotic. Oh no. I lost the flag. Or wait. Yeah. I lost my Basel's render. Here. Basel string. New window. CDC. Wait, this is CDC. Where do I put this? Maybe here. All right, here, read me. Basel's. Here we go. Yeah, 5 a.m. Today it's warmer than yesterday. Oh wait, what? Forecast? I mean, it's... Look at the forecast. Focus. What is this? 3 degrees? 3 degrees and 3 degrees and 3 degrees during the night. When? What? FU. Here, 6 o'clock tomorrow, like on Friday. 6 o'clock in the morning, it's 3 degrees outside. My plants will die. During the day it's 20. It's terrible. I hate it. Oh no, wait. Tomorrow it will be 17. 12. What? Yeah, it's basically, we have 12 degrees on Friday. Tomorrow it's 13. What? I'm upset. I need something to drink. Be right back. It sucks. I hate it. Snow warning? Johnny, yeah, it's your fault. We get wind from the north, the cold north. Yeah, climate change doesn't imply that it gets warmer. It just changes. It could go colder. Didn't you watch the phenomenal movie 2012? No, what was the movie? No. Day After Tomorrow? No. There was one movie that showed what happens if the Gulf Stream is cancelled. All right, peeps. Oh, wait. Day After Tomorrow, yeah. All right, so now is the issue. We have the code running on that, on the little MCUs, but the little MCUs. Long intro to stream. Since we are running on this, not on this, there is the issue that I don't have the GPIO connected to the MCU that actually would signal these MCUs that there is something on the bus. So I messed up. I might have messed up here. But what we can do is we can take, since we didn't use the low side drivers, we can use the GPIOs here and connect them to the exposed GPIOs here. So I just need to solder a plug that connects all. I can just connect them all to one. This is the same how on this one, like all the MCUs are connected to one GPIO here. So yeah, let's solder something, fix that, and then we can code and make it communicate. What? What? Reset what? Does the Linky do the halt on reset? Yes, it power cycles. But I need to disconnect it from the power on the USB otherwise. And I have also jumpers for that. So and it's important to not disable that. Ah, right. Okay, let me disconnect that. And let's move over here. We have some electronics content. Oh. Foo. Foo. Here we go. Okay. Cable management. All right. I'll just take this here, plug it in here. Yeah, I will do that. Oh, nice. Welcome. Nope. No eye lost during the process. I hope this is whatever. Wait here. The mini disc player. You move that over. The chaos here. The chaos. Here we go. I will just use. You can always rewatch them. Oh, live, alright. Yeah, that's difficult. Sometimes. I mean, the time that we picked for streaming is a sweet spot for the people who work during the day. Europe and some maybe in the. Here we go. Not really, but most of the viewers work during the day or they sleep. Stream at night. This is the wrong tip. I'm like 90% of the time I'm busy with doing bullshit like my taxes and trying to organize stuff and whatever. I wished I could concentrate on this work like most of the time, but maintaining everything is so terrible. As you can see, the more chaotic, the more is going on in my life. It's now probably 10 o'clock or something. I don't know what time is it, peeps? Europeans, what time is it? If I would stream like too early, then people on the West Coast in the US wouldn't be able to join at all. Now they can at least join in and listen while working. Okay. Yeah, I have a Steuerberater as well, but like so much of my earnings are in US dollar, and then I can need to compare with my bank account what was actually charged, because I get always crappy conversion rate. It's like really difficult. My tax guy isn't used to work with mixed income sources from all over the world and so on. So there's actually a lot of prep that I have to do right now, but I really want to let him do everything, including the billing and so on. I don't want to deal with that anymore. But sometimes you have to print it out. Oh, Okay, mine is quite advanced. They have a cloud, but the cloud is like usually Euro is stronger than USD. Anyway, so it's like a web form where you can upload up to 125 megabyte files, but it will fail. I tried to upload my text stuff to him, and it failed at 70 megabytes or something. I have like I think it was 250 receipts. I have a receipt for each like stupid server, each month, and each Discord and Blackmagic Cloud, and all the expenses, traveling stuff. So the expenses is like the most effort. What?
What?
Deals? Where? Sorry, didn't. What is this? This is. I need something with leaded solder here.
Oh, I should film that maybe. Yeah.
Isla? You mean Isla? I pay nothing on Isla. I just shared I shared just my Google Drive, because I also have Google Cloud, which has basically infinite storage, and I just shared the whole structure of my folder structure for all the expenses and everything, and they accepted it. That's cool. Nothing paper, everything digitally, and I just took pictures of the receipts that I had in paper form. So at least they're quite alright with that. But sometimes they're quite like slow, and then I get trouble with. Okay, I'm also slow and late. Anyways, oversharing here. I think we should have a trigger now. Loop. My headphones. What is that? T38. Okay. We will try to not blow up. Wait, where is my... Here, the cluster. There you go. Ah! Look at this. Cassettes! There we go. Yeah, we should have like a trigger pin. So let's test it. Okay, wait, this is... What is this? Which one is that? Is this the... Cluster raymarcher, okay. Cluster raymarcher. So, we should have like a bus loop. Bus loop. No, that's annoying. That's annoying. Yeah, I take it. Okay, not while one, bus loop. No, wait. Bus, read bus, or check bus, or how do I call it? So I don't want to loop it here. What? No, too much. It's doing too much. I need to turn it off. Okay, no code completions. Thank you. Can ask it later. Bus. Poll. Okay. So let's pull it. If not now, get GPIO peripherals byte yeah, no, I'm not we are done. We are done. User reads here, user reads programming. This is where I want to go. GPIO there are two difficult functions in computer science: naming things and cache invalidation and off by one errors, and also memory fragmentation. And this memory fragmentation is a problem that you're never aware of, but could happen. I don't know, I'm talking bullshit, but I had the problem already, memory fragmentation. Hello, I'm a boy. Who had the problem of memory fragmentation? If you ask FreeMem, it responds, yeah, there is enough memory, but it's so fragmented that you can't allocate a big chunk of it. You heard of it? Yeah. Nowadays, I mean, if you're programming for a PC, you have like almost infinite memory, but seems like normal memory. When back in the time when I was coding medical applications, and we were just loading string in Android, we were loading volumetric data from CT scans and ultrasonic scans. No. It's not where. It's not memory aware. No, the issue is that that's cool. Okay. You millennials are not aware of that problem. Let's switch to dark mode. I call you millennials because it seems, you know, okay, so you have a big chunk, your memory is basically a big chunk, linear chunk of space. Rage incoming, no rage incoming, here we go. And when you do malloc blah, like let's say smallest size is 16 or something, you get a chunk on the of that space here, the heap. Yeah, heap fragmentation. Yes, so you have, this is your heap, and then you allocate like, let's say you work with classes and you allocate a lot of classes, and it's almost like full. And then you're done with your work. Let's say pop, 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 pop. You're done with your work, and then you delete. Yeah, I know. You delete individual classes when you're done with it, and what happens is you have like small chunks of memory where you can't change the address, because in C++ you don't have a garbage collector, let's say like that. So the address is actually fixed. In like systems with garbage collecting, you could move chunks around and consolidate a little bit. Defragmentation, like you had with hard drives earlier. And now let's see, we have like here, this is free space. This is free space. This is free space. And if you ask like what's the command for asking for free space, you will get like, oh yeah, I have a huge space here. No, you couldn't, because you don't have like smart pointers. Usually, if you're using smart pointers, they could like maintain themselves in some way or form. But as soon as you got like here, this is my object, and then star, and let's say O, this stores a physical address on the heap. And you don't know where all the addresses, it could be copied 5 times, and you don't maintain all the references. Like smart pointers would like O2, smart pointers would like maintain at least the count, so they destruct themselves if they know, oh yeah, there is no more copy of that address anywhere. So that's what smart pointers would do. But there is no way of knowing where all the pointers to this memory address are. That's why you can't move this chunk anywhere else. So what you could, on CPU level, you could do this, because memory is like working in 4 kilobytes chunks or something. Memory pages. That's why you can have like memory pages on your drive, like virtual memory. So the modern CPUs can handle that in protected mode. But this is like hardware level. So we are way lower here. This is all like heap. That's one thing. And yeah, so if you ask, I had this also with the ESP32. If you ask it like the wrong question, what's the malloc here? CPP reference. Where's oh yeah, it's free, not delete. And wait, but where is what's the free mem. I want to talk bullshit. Oh wow. It's so funny. I get expressive documentation shown. Okay, so where's the system available heap? Okay. So minimum free. Okay, get total minimum free memory, but there is like largest free block. So actually, you need always to compare if you want to allocate. The misconception could be like if you ask it for give you the free memory, you get a bigger chunk, like bigger value than actually is like available somewhere on the heap. So like this is the largest block. So like one block, and this is like the sum of all the free blocks including that. So if you ask it to give you the free memory and then you try to allocate, it will fail even though you asked it to. So what you need to ask it, especially like on microcontrollers, because they don't have like a lot of heap available, you need to like find like the largest free block or something. So you know, all right, there is a block that's big enough for my data plus the header, because you need like 16 bytes of header or something for the memory. Cigaretta, hello. So that's heap fragmentation or memory fragmentation, whatever. And apparently I had this problem the first time I encountered it when allocating big volumes. You have usually like a cubic volume of scans, which are 500 by 500. So you have basically 512 squared. And then you have like a scan can have like 200 images of that. So if you want to access that for a software renderer or something and load this whole thing in memory, yeah, you need a big chunk of available memory. So if there a defragmentation function to call, no, there is no defragmentation function. You would need like to clean up your memory manually in C or let's say C, not C++, because there are tricks that you could use. Get free size. Let's see. Digging the scarf. Yeah, right. Here we go. Yeah. Be always aware of fragmentation. It can happen. You have a lot of, I have enough free memory, and then bam, fails. Malloc fails. Or new fails. Especially malloc of bigger bigger spaces. Anyways, here we go. Oh. Yeah, me too. I never check, especially now. I mean, when I was working in medical, I had to, but now I don't care. That's hobby projects. Bool. Yes. I worked different fields even. Medcom. I don't know if I here. This is where I worked for 5 years. Oh, interesting. So on Centra Prostate, big part of that software, I don't know, probably it's maintained. Yeah, software. I think I did a little bit of prosoma biopsy. Interesting. Yeah, there's like a lot of shared code. It's interesting. There is no like a few of the projects aren't there anymore. But on Central Prostate is basically one of the major things that I worked on along. You can see like here's like displays volumetric. Oh wait, this is gynecological probe, maybe even, or is it no rectal probe? Okay. Okay. Is there any pictures? Let's see. Nucatron. No, that's not the right one. Not software, not firmware. I wasn't into embedded back then. That was like 15 years ago. And I also worked for Exocad, like dental software. Your father worked for Nucatron, but Nucatron, the Dutch company. No, but I don't think you can even see parts that I did. Yeah, they bought a lot, and we basically did white label for them. They are located in Veenendaal, so I had to also go to Veenendaal in Netherlands to headquarters. Dandy, yeah. Yeah, it was that was founded by a friend, by friends of mine actually, and they got really successful, and I'm really happy for them. And then I worked a little bit after my startup failed. I worked for 2 years, and it was just to Smile Design. Wait, this is what I worked on, actually. Isn't that my face? That might be even my face here. This is what I worked on. This is my team lead. Yeah. So this is, but that Excel cut was 2017, I believe. Startup, yeah, I had two even. Interesting photos, yeah. Now I'm sweating. Either it's fever. We should continue. I still have this clip. I kept it. It might be here. Wait a second. Oh no, it's not here. I know that I kept it. Of course you keep it. I mean, it's a one-time use thing. I don't have it here actually. If I find it, I will use it. It's looking strange, like spreading lip spreader. Whoa. This is going the wrong direction. Okay, peeps, let's implement the function that we want to use here. Get IO0 and then also get IO1. So now this is programming phase. Is this IO0? Yes, it is IO0, I think. Yeah, return. What does it return? All right, here we go. And GPIO 2, I think, yeah. So what we want is that's programming phase. We don't want that. We want now bus poll or bus wait. Let's do bus wait. We want to wait until we get anything from the bus because we are only clients and we have a host. While get IO1. Why not? Idle, and then first we read command and address. $32 bits, that's all right. It doesn't matter in that case because we this is native size. We could do bool as well, but yeah, I want to keep it 1 and 0 so we can shift around stuff and do bit operations and whatnot. So I'll keep it like that, and it will stay native size, so it's the fastest on that MCU. Read command and address, so basically this is that. Bus A address, then switch command, default is oops or let's say no. Case bus get UID bus set index. That's the first thing that we need to implement. So if we want to program the index of the MCU, because we need to identify at the end which MCU we are talking to, and we also need to to know which pixel it renders at the end. So set bus index is basically programming mode in that case. So if get IO0, by the way, it needs to be this. Read bus A. I'm wondering. Yeah, I don't need that here. We'll be doing that. Okay, so this is like a special case because it doesn't have an actual address yet. So we need to check here if get IO0 in that case the LED needs to be off. Then we set the index to address, because so we have both GPIOs triggered, so we can pull up the LED from on this board. We can pull it up and then we set the index, set MCU index. Let's be really descriptive here. So set MCU index, and then we do the programming thing here. Yeah. Yeah, we only want to do it once. Address, it only supports 8-bit. Set MCU index, and then also while get okay, so we want also to wait until it's finished so we don't reprogram it twice or something. Might. Hey, thank you for the follow. Tatsu. Big int. We could even skip that. You know what? We could skip that thing here. It doesn't hurt. Doesn't hurt, okay. Even hurts flesh less. Some people will understand. Set MCU index. Okay, so we are capable of break writing the index. Then we are case pulse blink. Oh wait. No, actually, we want this loop here. All right. Let's do both bus loop. Whatever. Now we never go out of the while loop again. So also we want to this case here. If wait, tasks, where? Here? What? If oh, I made it okay, let's do it like that. If okay, let's do it camel case. Where's this MCU index get? Okay, easy. Need to organize this a little bit. Okay, in that case, continue. Yeah. So check if talking to us or if setting the MCU index. Good night, 4-4. Okay. Do we wait for the next? Okay, so while we wait here, while do that, wait for next command. Okay, and then here we go. Okay, so if we continue, it will wait for IO1 to go low again. And all is good. All right, bus blink. Let's do that. That's blink, I think. Yeah. That's just blink. Blonk. Break. And that will be it. Huh? Oh. Huh? What? What is it complaining about? Oh yeah, blink here. Alright, yeah, I don't care about this. Yeah. Blonk. I don't know, it's maybe a longer blink. Hey, Marcelo, thanks for the follow. Blonk. bus raymarcher init. Oh really? I'm not stationary enough. Is it bothering you? Okay, case. Render pixel. How do we store the result though? It should go into, okay, so basically what we can do, we can do that static, but I don't want to make it ugly here. I make it even more ugly by using global variables. No. Vec3 pixel color. So raymarcher image pixel color equals render pixel oh wait, no. Yeah, but every single renderer needs own starting coordinates and direction. They would use a broadcast. Oh yeah, by the way, broadcast is 255. So and broadcast. Okay, so we have only 255 MCUs. This is the broadcast. Good that you remind me of that, because there is also what I want to implement later. Send a whole scene to all of them. No, everyone will hold a scene, but then you send. I will show you how it looks like in the renderer. We have that already done here. Where is it? No, it's not that one. Here. Boop. Hey. Wait, what? Oh, this is not that one. Ah. That's not the one. Here. Oh. Okay. So raymarcher MCU. Okay, here we go. So what happens here, I will show you. You can also check out the code. It's on my GitHub repo. Render stuff. Next pixel. Worker done. Okay, so render does that. It calculates next pixel is basically the origin and the direction for the next pixel, and worker's push and then send data. Let's go to send data. Okay, send data generates an array buffer, a binary array buffer that has like 25 bytes. This is the code, the serial code. Okay, here comes a pixel renderer request or whatever. Then we have it's sending three 32-bit integers for the origin and the direction. And this is basically what we want also to keep for the little MCUs, but the main MCU will basically distribute it to the individual ones and then return the pixel that was rendered. What is missing here is the pixel ID. So because we could send it like more and more and more and more, like 160 different coordinates, and it will handle them like pass it to the little MCUs and return them by one. So we would need to change here, add like the ID, and then since we have like workers, I think there should be even like an ID. Wait a second, where is the ID? I think I handled it somehow. Receive data. Yeah, this is basically here. This will be the ID. The pixel coordinates, they are stored locally. We just need an ID. So the worker stores basically, or the pixel stores the coordinates of the, wait, let me check, worker got done. We can store pixel Y and X is stored in the worker, and we are not transmitting the coordinates X and Y because it doesn't make any change or whatever in on the little MCUs. We only need like ray direction and origin, and that's it. So we can store them locally, and the only thing that we need to do is could the little chip do a set of rays if given region or larger NDCs might be less bandwidth, returns 8 by 8 pixel square instead of, yeah. We could do even chroma subsampling. Of course, but this is all optimization. And we don't need to be data efficient if we manage to set it to 8 megabits per second. Super sampling. Compression. We can do a PNG compressor on the main MCU because the bottleneck is the serial between main MCU and PC for now. The other bus is capable of doing what? A lot of megabits, bytes. We can probably transfer like, I don't know, 8 megabytes a second with the bus. Not sure how fast it is. Christian, that's a cool cat. When did we get this one? This is cool. Alright, so so we will just pass the ID, and then we have like a block of we could also, so what, maybe Sonic, you can share a link to your HDR renderer, because currently I'm returning 32-bit colors, which is way too high. I could return like 8-bit, but with the possibility to render HDR, we probably want to return like maybe 10-bit, 3 times 10 bits. share it to the other chat as well. Is it working though? Oh, wait. Let's run it here. Oh, what did I paste here? Ah, that's all right. Here. Here. HDR content incoming on a non-HDR stream. Yeah, 10 seconds on your PC, Threadripper or something. It's a little bit longer on my system, that's actually quite busy right now. But no frames skipped. Ah, here we go. Ooh. Do you see the difference? Nice. Yeah, blown out, blown out, blown out. Bam, HDR, tone mapping. Cool. So, yes, we can do HDR even with fixed point arithmetics. That's so silly. Anyways, side. Okay, render pixel. We need to read data though. Read okay, let's do render pixel here like that. Render pixel, read bus byte. We can use even, yeah, we use the address. It's not the bottleneck, we could use it. Oh yeah, there is one thing I maybe wanted to also share. How what I'm thinking, how to optimize the stupid polling mechanism of the bus. So usually the little MCU will wait in a loop and check if there is like something incoming for on the bus, and then it's the right ID. So I match me on the address, right? So but we can do a broadcast. So what on the main cluster we can use one wait, let me change that. The design is like follows. Oh shit. Yeah. Design is like follows. We have this trigger line that tells it, alright, we are... Come on. Okay, the trigger line that tells it, yeah, there is a new command. We have one command line per 16 MCUs. 16 basically, like that. So we triggering 16 at the same time. We can do that. We can trigger all, because that's in parallel. We can trigger all MCUs at the same time, doing stuff or whatever, blink once or start now, or if there's like some scheduled stuff like an animation, let's say a 3D animation, you want to trigger it once so it starts at the same time, more or less, or give it some sort of trigger. But we can do like a broadcast, so we can tell it, oops, we can tell it ID, not me, we tell it ID 255, whoops, 55. So all the MCUs are triggered, and if we have like a command cmd idle, we can let all the MCUs set 1 bit in the next cycle, set 1 bit of the address and the data, if they're idle. So the MCU can use like one bus command to check which MCUs are done with their work, and then read the MCUs, address the MCUs individually. So that's like an optimization step before, like we start with polling each individual MCU. It doesn't like, I mean, it takes some cycles, but not significantly. We need to do it 160 times, and they'll be busy. I don't know how long it takes. Like we lose maybe a millisecond here and there. But if we want to optimize that, we can do like broadcast comment that says, "Oh, set a bit if you are idle," and then we have like repurposed the address and data buses to set like a bit of each MCU. So the MCU takes basically their ID and 15. So, and then 1 shifted by is basically, we just need to make sure that all the MCUs that are connected to one of the trigger lines are like the lowest nibble sequentially or whatever addressed. There's no like crossover and 2 IDs having the same thing. I mean, you can do whatever you like, but this is what I thought of optimizing here. But we're not talking about optimization. Function first. Read bus bytes. Okay. We can do read it won't pass the pixel ID to the MCUs. That will be maintained by the main MCU. It will have like, okay, this MCU covers this pixel ID or this work ID, and then we return that and be good. Read bus int 32. And then if not, well, we should make it bool here. If not, read bus return false. Okay, so we just return return false. Okay, we have int 32 t x y or x pause. Wait a second. We can do back 3 pause back 3 dear read bus back 3 return and then pause read bus back 3 dear. And now we just need to do depth is 2 hard coded for now. We could initialize it. Oh yeah, ID. We can do ID here. We don't need to pass it here. Render pixel ID. Pixel. Okay, wait. Event 8t ID equals MCU index, and then we need to set MCU index and then ID equals address. So we don't need to get MCU index all the time, ID, and then we can always compare if we got the right data, because there could be something wrong. Render pixel. Why does it complain here? Render pixel. Oh yeah, here. 8t. Read bus. Okay, so what? Are they going to use a packet struct to serialize the packet of data? Yeah, basically, I'm not using a packet struct right now. If it gets more complicated, we can do this. There will be certainly a packet struct, a serializer. I started already doing a serializer on the MCU thing. I think there is even like a serializer or no, wait. In the implementation of that one here, Ray main. Yeah, there is already a serializer which does it for serial already. And we have write, read, and whatever for serial. But on the parallel bus, it will be different. We can do it as serializer, deserializer, but I will implement it now in functional form. And then once it's working, we can optimize that or make it beautiful. Read bus back 3 uint ID, which basically will check at some point if that I'm blowing up the stack with passing this ID or here. Back 3. We can do ref. Should we do it like that? We could do a reference here. Yeah. Okay, let's try that. We are in C++, we can do that. All right, so at least this enforces that we give it an actual instance. Okay, vec uint 32t I, and we don't need to read if not read in 30. Read bus and 32 ID I. We need here render pixel, and we need the pixel color. Just want to clear my head stack. Pixel color. Vec v0 equals I. Copy paste. Now little endian people, little endian. Oops. So I equals 0, and then wait a second, did my chat die, my bitluni? I can't hear anything. Are you not there? Okay, B. Return false. Okay, read bus byte. We can do it all inline. Say something. Oh, Christian, you're muted. That's why I was wondering. Then it's all right. Return true. It is return stuff. Ah, yeah, that works. Thank you. Read byte. Okay, so now here we wait for next idle. Then oops, wait, next clock, and then the read basically if we could double the speed if we are using address as well, but if the others are listening, address would be bad. Know how to fix that. We have too few IOs for that. I should be using like both IOs. I don't know. The design is flawed. So if okay, so read bus byte, then we use basically little endian first, alright. So we do that. B, and then what's going on? uint. Where is it? Oh. Okay. And then let's do the other bytes. Oops. We don't want to What? You're going? Good night, DFGA. Okay, big endian. 16. You in. Okay, return. Okay, let's put all that balls back. I will put this stuff in the bus part. Where's bus byte? Huh? Oh yeah, I'm missing the. Oh, thank you. That would be some debugging here. Oh no, not here. Eh? Oh no, wrong. Here, this one here. Yeah. Copy paste error. Here we go. Alright, bus vector blink set MCU index get IO. Maybe I should also put this in bus. Yeah, it's OR, and bitwise OR. Write ID / define. Who uses defines nowadays? You can do just that. Const int. I don't want I'm sorry. Yes, it's open drain with pull-ups. The pull-ups are there on the board even, so I don't have to do this, because if you have 160 MCUs that are pulling up on the same pin, yikes, might not be great. If it's too slow, no, I have like, I think one K. I took 5 Ks maybe there. I can't remember. /option init timer enter peripheral init LED read bus. Okay. Debug F init bus here, and then we have init bus. We take that as well. It's too much in one function here. Init bus, so everything bus related is there. We could even do render pixel. This is old news. Const expression. Yeah, it's const. Here. Defines are only useful if you're using, like, trying to comment out blocks or something. Const expression. Why? What is the difference? What's the difference? I want to learn. Specifier declares that it's possible to evaluate the value of the entities at compile time. Oh. But const, is this a difference? Yeah, I mean, all right, here this will be optimized anyways. It can't be changed. Oh, but it's still like in the memory somewhere. Okay. I learned something. That's cool. That's cool. Oh wait. That's the flash. But I need to be sure that that's no address or something. No. Because if there's like an address stored, yeah, we take that constant. I like it. It's better than defines. Yeah, we can. Yeah, we don't want to take addresses of that. I never learned this. I'm forgetting stuff like that. Okay. Anyways, I'm too numb. Okay, depth, pixel, pixel color, render pixel. We can just return, bool render yeah, static is unnecessary. It will be static anyways for consts. It's just not used everywhere. You could have like a different const. Is it even shared if you have like the same const with the same contents in another function? I think it might be end up being like in global space anywhere, like a static. Because you can't change it. They put it probably you could put it in slash in code segment or read only segment with other strings or something. It depends on the compiler and the optimizer. Render pixel result. Or send render pixel result, and we will do write pass back. How do we write even back? I don't know. We don't need ID though. We keep the ID. We could verify if it's right bus and then not position, we color pixel color. If not, and false. Might be something else. Christian, I can't hear you. Oh. Okay, now we write pass back. Right pass back. This is now interesting because there are not many people chatting right now. Alright, so why did it complain anyways here? What was that? Oh, we have int Oh, I did. Int and I did uint. No, where is it? Yeah, I did uint here. Okay. Read bus, write bus, write bus. And write bus vec 0. Oops. Okay. Turn true. Okay. So write bus and then we just need the read bus byte and stuff that here. Yeah. Right. And we don't need a reference here. For loop mnemonic. There is a loop in x86. There is even a loop opcode that counts like loops and decreases CX or ECX. So CX is the counter. And you loop until CX and decrease CX. Okay, write bus byte. Clocked path. Now we need to set write bus A. Bus A with the byte, no, ID. Oh, yeah. Yeah. So, thank you. That would take a long time. Hey, hot. No, I can't read this. Why is it so? Thanks for the follow. I couldn't read your H. I couldn't read your name. What? Oh, this is. I can't read the names. Wait, Hocus Pocus. Thank you for the follow. Okay, write bus A. So okay, we wait for the clock to go down. We set our bytes. Write bus B. Then we wait. Flash the name on the wall. Yeah. Extra tasks on my wait, clear, clear means writing. Wow, I see that I wait for the clock to pass, clear the bus. Oh, there's not much we have time for, so we will see how fast it works. What? VP Mult Shift QB? Anyone? I used SS. I stopped when there was like streaming extensions. SSE3 was the last thing I used. Yeah, what? now the assembler pros are coming out of their holes. Alright, so write bus and then return true. Clear, write bus A, clear. So, write B. Okay. Yeah. x86 was my 90s and early 2000s. Sonic, may I ask how old you are? I probably asked already, but how old are you? On your cover picture, you don't look that old. You're 50? What? Wait a second. On your Discord picture, you don't look like 50. You look like 30. Maybe 35. No. It's not. Peak age. Might be a bit older, the photo. Alright, okay. That's alright. I have also like a 10-year-old photo on my Instagram. I really just don't care. That explains a lot, because you're speaking like a person with a little bit more experience than a 30-year-old would do. Nothing against the 30-year-olds, but some tech is so old. Like, I was wondering, how did you own like a Walkman or something if you're 30? All right, wait, where was I? Here. Right. This was void. Oh, okay. Yeah, that's a bit older. 20 years old. Clear. That's what I looked like with at that time as well. Clear is basically F because it's open drain. Oh, really? There isn't one major flaw with basic. It's starting counting at 1. It's so late already, damn it. Real mode. Peek and poke in basic. Okay, peeps, where did we start? Write, bus, byte. Okay, so return true, then yeah, I learned MIPS in college or university, whatever you like. Right, okay. You know what I like? I like to shift by 0. Boop, boop. Now, what do we do? 16, 24. Here we go. Okay, what does it complain about? You can't use 32-bit non-constant one. Oh, wait, what? Here. Right, bus byte. Here we go. Now it should work. Okay, we are writing stuff. Read, write, bus, vector 3, and then return true and be done. Whoa, 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 whoa. Oh, wait, what? We can also do this int. Wait, we should do int everywhere here. This is not performant. Even though it might take more stack. No. Let's use this. The pixel. Something's off here. Something's off here. I'm missing. Oh, here. Pixel. Okay. All right. So yeah, bus raymarcher init, render pixel. We ignore the result. Oh yeah, and break. Return. Send. Okay. We implemented everything without one test. Oh yeah, we're not initializing the scene though. So maybe we should initialize it. I don't know if I want to do it once or multiple times. Load scene, yeah. Let's do load scene. I prepared deserializing here. Okay, render pixel. We're not doing anything here. We are just no, it quits at a specific far distance. Bus loop. Let's do bus loop. Didn't I use camel case here? Actually, I didn't. Okay. Almost. The code is done here. This is the code for 5 problems. Init bus. Yeah, okay. I need to import earlier. And I also want yeah. My naming convention is don't use spaces. Okay, load scene. And then we need to... What is this? Where is this going? Why is it complaining here? What? Expected primary... I don't know what's complaining about, but I will usually you wouldn't need a break there, it just leaves the switch case. You need, why isn't it implicit? I don't think so. That's not the case. Break is optional. Expected primary expression. Include bus Or is it here? That must go to the start of it. Maybe that solves the issue, and then I can remove the break even. Break even. Only warnings. Oh yeah, we don't need that. Oh yeah, here, return true. What else? Unused variable, yeah. We don't need that. Where is it? Yeah. Okay, this is Hocus Pocus. What we are doing is, since you are new, these here, right? Here. This one here, this is a cluster of 16 MCUs, and this is one big MCU, and we can talk to the, let's say, to the big MCU for now. Okay, I need to resolder it on. We can't test it now. Yeah, anyways, what I wanted to say, it's breaking. Yeah, this is, no, not this one. Which one was rendered? Yeah, breaking stuff. Where is it? Yeah, that's everything. I will solder this like in a second. Where is our fixed point raymarcher? No. So we can render this on the MCU with fixed point arithmetics, and now we want to distribute it on multiple MCUs. I will quickly solder that on again, and then we'll be back in business. Mayhem. Why is it detached though? You want to see how I work? Yes, you want to see. Wait, I have a microscope cam. Maybe we can do... No, that didn't rip the pads. Wait. Where's the microscope? I think that... It is, I just... It happens sometimes. I rolled over my USB cable as well. Quick fix. But also I need to heat up. Probably the bismuth solder isn't that great. I have no space here whatsoever. Why is everything on the floor here? All right. All right. Yeah, it wasn't really soldered properly here on the sides. I soldered it from here, but that's not good enough. I need to solder it properly from the sides as well. I will use maybe the leaded solder here. I hope I don't bridge it though. No, bridge. Okay, here we go. I will use this here to really solder on the case. Yeah, now it's fixed. Not enough flux here. The linkies are dangling around here. All right. I think this should be good enough. Let me clean that. The toothbrush and some IPA. I got it from eBay, like a 5-liter canister before COVID happened, and it was quite cheap. During COVID there was no way of getting new IPA. You don't need like the purest quality, like 99.99 or whatever. It is, I think it's 99%. The first ones that I got were like 1 liter bottles, like this one here. It's 99 point. Yeah, 99.9, which is all right. So I don't need to dry anything actually. I can just plug it in and be good. So that's just from eBay. Okay, it doesn't blow up. Let's see if the renderer is still running. Oh. That was the acknowledging blink. Where is raymarcher with checkerboard fast inverse square root? Open paper. Where did I? MCU raymarcher, here it is. Okay, does it run? Uh-oh. Not recognized. Maybe cold solder joint. Need to check again. I don't think so. What was it? USB log view. There we go. I will check with bigger. Oh, it did. It did now. Huh? Oh. Okay, it works. Strange. Yeah, okay, that works. But it looks like we are not progressing a lot. It's so late already. I don't think we can... I mean our MCU... Wait, this is not the one. Okay, we can program this. Okay, I can try to pass all the pixels to one MCU after I indexed it. But I think I have indexed MCUs. Oh yeah, I have indexed MCUs here. We would also need to create a copy of the raymarcher thing. Where is I? Where is I? Okay, supercluster 2 CDC renderer, and I do a copy of that and make it cluster raymarcher base. Okay. Is this the CDC? Can't see. No, this is cluster raymarcher. Oh yeah, let's program the MCUs. So I will try to upload the code. Oh, I could upload the code to these ones here who... Oh shit. Oh, they're going wild! They're going wild! Hey, this is the wrong one, man. They should not go wild. Yeah, let's upload it and see if they're still go. Where am I? Huh? What is going on here? Oh no, it's alright. Okay. No, not pink LED. Unfortunately, pink LEDs are not available for an JLC as a simple part in 4.04 or 2.02. Alright, so we have that part. Now we need to program the other one with... Ah, fuck. This is how I rip off my stuff here. This is the second linky. Okay. This was raymarcher, okay. Then we have CDC renderer, file, open folder. Okay, here. Now we can mess around with this one. It's initializing stuff. And we need to copy stuff from the cluster programmer. So we have also the bus thing, but we will copy it from somewhere else. Then we have that here. Okay. Whoa, yikes. Almost there yet. We want to try to render at least from one MCU today, but this will take another hour, I believe. This might be getting complicated here. Serializer, okay, serial, return, fix. I will put everything from the other stuff here. Okay, set bus data. Okay, set bus data. Bus needs to be included earlier. And there will be one quite similar, but not so much, because we want different hardware layer here. Why didn't I call Pragma once? Yeah, alright. Read bus. We have read bus data and so on. Wait. Main. While true switch get you int. Okay, so we want to not render anything here. Basically vec3. That's all right. Load scene doesn't need to be done as well. Alright, that was test. And we want to do all that stuff. Button pin, okay, interrupt. We don't need that. Usart config. Oh, we don't use that usart config here. We can do the main down there. I will mark it. This is something that I can't brief, yeah. Old programmer. We put it here, and now we need all that part. Oh, that writes user byte every time. Oh, that's a terrible code. A delay in it. Usart config. I would call it set MCU pin 0, and we need also to set GPIO. Oh, this is so hard. Too many things at once. Sysdig, yeah, we don't need that yet. GPIO, this is basically for column pin, column bank. That's MCU, MCU bank, column, MCU. Okay, what do we do with MCU pin? That's that. Pass pin, GND. Oh yeah, that's what we want. We want to set, this is GND pin and GND bank are basically our base, our clock signals. Okay, peeps, I don't know, it feels hard to have no closure today. I will try to, if I don't feel like totally wasted, I will try to set up a stream on Friday and we can continue, because that feels like I want to sort everything. I can actually try to upload code that has CDC renderer. Wait. Oh no. Yeah, really? Cluster raymarch. We can add. Wait. CDC renderer, cluster raymarcher. Wait, this is the wrong readme. No, CDC code based off, okay, that's alright. Raymarcher base, cluster raymarcher, okay, we can do that, or let's do that, plus first raymarcher version for CH3203 including bus communication. Alright, here very verbose. CD renderer, stage this, documents, wait, they add, no, this is changes, yeah, stage changes, source. Okay, that's that. And okay, so I upload, I will sync the code. First raymarcher, it's erst raymarcher. Yeah, so first without F here, erst raymarcher. How do I push it? How do I push the chain? Oh wait, here. Push, push, push. Here we go. All right. Yeah, I don't bother. It don't bothers me. Triggering people. All right. So next part, final 2 copy 5 will be executable. Will be programming that device if I didn't do it tomorrow during the day. If I'm sick and I don't go to sports, I might schedule the other streams, but I really need to rest. I will try to make that running, and if that runs, I will try to get this thing running, which will be a struggle. And if this runs, we are good. We will be able to test on Friday or Monday, depending on how I feel on Friday, what the result is. But at least I was able to show you things. Final countdown? Yeah. It's the final countdown. Okay. Nice goodie. Nice goodie for last here. Look what I got. Where is this? Here, unboxing time. So I have this 14S prismatic cell battery. Polygons, that's a ray tracer or raymarcher. You just need a distance function. It can render anything. And this one has like these two, it's 14 cells, so we need some balancing here. It weighs like, it's 2 kilowatt hours. Weighs a ton. And yeah, I want to use it with my solar. So I bought this thing. Look at this thing. This is a BMS, 14S BMS, and it has Bluetooth. You can configure if it's lithium ion or lithium iron phosphate or whatever. Yeah, this is the balancing wires. It came with wires. It's small, and this is 40 amps. No, I don't want to. I will be very careful. Although I need to like disassemble the long balancing, the big. I will do it outside. But I have a CO2 fire extinguisher. When you need 10 batteries, yeah, 10 years. No, I don't think my MCU will drain 2 kilowatt hours in 10 years. Yeah, it will. We could calculate that. Interesting calculations. Okay, so we can run our MCU of 3 milliamps. So 2 kilowatt hours at 40. Wait, this is 3.3 volts. Yeah, we need like 10 milliwatt hours or something to run the small MCU that ray traces a scene. So we have basically 100. It's 2 kilowatt hours. Wait. Two kilowatt hours. So we have 200,000 hours. That's 8,000 days. $22 years. If we don't use an LED, we can run one of those 10-cent MCUs for 22 years from this battery when it's full. It probably the wires will decay. Yeah, we need to turn off the LED, otherwise it's only 10 years. Unbelievable, I wouldn't think that. Primary cell. Oh, by the way, the Perovsky cell is still lit. Still working. Alright, peeps, I see you next time. I will prepare stuff so we can actually play more hands-on, playing around with our cluster. Oh, Johnny, thank you for sub. Now 17th month. 17th month. English language. Ridiculous. Here are the QR codes for the app to program the device. Here. Alright. Bye-bye. What? Rohan! What? That's good news. We get closure after all. 32 bits. Alright. So, have you been able to run it in a VM, or are you trying it on standalone PC or whatever? That's interesting. So we might be able to configure it. Saves you trouble. Oh. Huh? it failed. How does the app then work? PCI pass-through failed. So it just started, but you weren't able like to do whatever. So we probably need to install 32 bits. I will get the PCI Express card tomorrow. Oh yeah, we will test that. So we have a lot to do. I will try to put also the flash on the M.2 matrix so we can run it faster though. And then use adapter. Oh, alright. Nice. Okay, thank you for testing. That gives me the assurance that I need to do that as well. Alright. Good night everyone. Bye bye.